Okay, this will be an example of solving an equation that is quadratic in form. This basically means the equation we're given probably won't look like a quadratic, but we can turn it into a quadratic equation fairly easily. So this example is actually a rational equation. So this will remind you of some of the work we did back in Chapter 7. And what we know about solving rationals is a good step is to find a least common denominator and to change each fraction to have that least common denominator. And turns out that makes our solving process run quite a bit smoother. So let's go ahead and set it up in a similar way that we would have back in Chapter 7. So I'm just making some room for my LCD here. When we talk about the LCD in this example, it's actually going to be the product of all three denominators. And that's because there's no overlap in the denominators 3 minus p, 5 minus p, and 15. So our first fraction will need still the factor of 15 and the factor of 5 minus p, top and bottom. Our second fraction will need the 15 and the 3 minus p. And the final fraction will need the 3 minus p and the 5 minus p. So again, we're just giving each term what it needs to have the LCD. And then what happens next is the nice part. Essentially what we're doing is we're going to multiply the whole equation by the LCD, which in effect cancels out the denominators. So we're really just going to clean up the numerator now. And let's see, we'll just go ahead and take a few steps to do this. So how about 4 times 15 out front of our first fraction gives us our 60. And 2 times 15 out front of our second fraction gives us our 30. And I'm going to go ahead and leave my 26 out front on the other side and just FOIL. So we'll have a 15 minus 3p minus 5p to really give us a negative 8p plus p squared. So 15 minus 8p plus p squared. We're going to keep cleaning up. At this point you might observe every term is divisible by 2, so I'm going to go ahead and knock them down by a factor of 2 just to keep my numbers manageable for working by hand. Just do that real quick here. So instead of 60, we'll think about 60 divided by 2, so 30. Instead of 30, we'll think about 30 divided by 2, so 15. And then over on the right hand side, 26 divided by 2 to give us 13. And I'm going to go ahead and rearrange my inside terms while I'm at it to put them in a better order. Okay, so it's starting to look a little better for us, hopefully. We'll go ahead and distribute to finish up more cleanup. So we'll have 150 minus 30p added with 45 subtracted by 15p equaling 13p squared minus 104p plus 195. And I still have like terms on the left hand side, so I'll just go ahead and care for that now. We're going to be looking at a negative 45p plus 195. We're all cleaned up on the right hand side, so just bring it down. And at this point we should recognize this as a quadratic equation. The power of 2, oops, that I almost forgot, helps us recognize that as a quadratic equation. So I'm going to go ahead and send all my terms to one side, set it equal to 0. We'll see if it factors. If it doesn't, we could always use the quadratic formula. So I'm going to add my 45p both ways and subtract my 195 both ways. Uh-oh, I'm just kind of missing some pieces here. Sorry, there we go. And we now have 0 equaling 13p squared minus 59p plus 0. So let's think about what we have here. This will factor, and 13 and 59 don't actually share a common factor, but p squared and p do. So we can go ahead and factor out a p. that leaves us with 13p minus 59. So at this point, either p here is equal to 0, or 13p minus 59 is equal to 0. So we're using our zero factor property. If this were the case, that means 13p is equal to 59, which really means p is equal to 59/13. And we already said those two numbers do not share a factor, so that would be in reduced form. So we have two solutions that we're thinking we have to this equation. Before I write them down and call it good, though, I'm going to run back up to the beginning and consider my domain. Oops, because I have not yet considered the domain for this problem. So back up in our original, the domain would have told us, and I'm going to make this messy here and just write it right up top here. The domain would have been all values for p except for what? So all values of p except for, this guy says don't include 3, this one says don't include 5. So the domain is everything but 3 and 5. So I did have to consider that for just a moment. Now running back down here, oops, having some trouble getting down. P equaling 0 and p equaling 59/13, both of those are fine. Neither of those were excluded by the domain. So I'll go ahead and just put those two values in our solution set and call it good. So two solutions, 0 and 59/13. And that would be an example of solving a rational equation that turned into a quadratic equation.